Today we're looking at work problems. So the big idea here is that two different people or two different machines are going to take a different amount of time than the other person or the other machine to get a job done. However, if those two machines or those two people are working together, the job is going to get done more quickly if they're working together on it. Okay, so what we can do to solve work problems, we can begin by creating a table. Okay, so let's say we have a large water tank that can be filled in 8 hours. Okay, if continuous pumping using pump A. All right, so it takes pump A 8 hours to fill the tank. Okay, now if we have a smaller pump B, and it works with pump A, so if smaller pump B works with pump A, it only takes 6 hours. To fill a tank. So the question is if you were only using pump B, how long would it take to fill the tank? So how long to fill the tank with just pump B, which is smaller than pump A? So, in your mind, you know that pump B is smaller than pump A, so you know that pump B should take longer than pump A. So, your final answer, just using common sense, should be more than 8 hours. Okay, that's spelled hours really strange there. There we go. So, we know that it should be more than 8 hours using pump B because pump A is a larger tank and it took 8 hours just for pump A. Okay, and we know working together they take 6 hours, which also makes sense because they were working together. Okay, so this is how we plan, right? So we make a table. So in this table we have pump A by itself, pump B by itself, and then we have them together. Okay, and then for this chart, we're going to look at two things. We're looking for the hours it takes, and then we're going to look at part of the work done in 1 hour. Okay, so in hours, pump A took 8 hours. So how much work did it just 1 hour? Well, if they're working by themselves and it takes 8 hours total, then 1 hour, pump A has completed 1/8 of their job. For pump B, we don't know how many hours it's going to take pump B. But however many hours total he has, if we want to know how much work is done after 1 hour, it's just 1 over however many hours total. And then together, we know that we have 6 hours, which means after 1 hour, they've completed 1/6 of the job. All right, so this is where we can solve, okay? Because we know that part of the work done in 1 hour that has to be, these have to add up to the together, okay? So, looking here, we're gonna set this up. What the work that pump A does in 1 hour plus the work that pump B does in 1 hour has to add up to the work done with them together. So we have 1 over 8 plus 1 over x equals 1 over 6. So this is a rational equation that we have to solve. So the first thing we want to do is kill our fraction. So to kill our fraction, we're going to multiply by the greatest common factor. So it looks like we need an x and the least common multiple. So we're looking for the least common multiple. So for the least common multiple of 8x and 6 would be x, and then the least common multiple of 8 and 6 is going to be 24. So we're going to multiply every single term by 24x. All right, and then we'll see things cancel out. 8 goes into 24 3 times. X cancels this x. And then 6 goes into 24 4 times. So we're left with 3 times x times 1, so 3x, plus 24 times 1 is 24, equals 1 times 4 times x is 4x. So now we no longer have denominators, which is what we wanted because we wanted to kill the x, right? So now to solve for x, we subtract 3x from both sides. So now we have 24 is equal to x, which means that x is equal to 24, which was the amount of hours pump B takes to fill the tank, right? So how long does it take for pump B? 24 hours. So pump B takes 24 hours. So it takes a whole day. Which, if we look at our problem, makes sense because 24 is more than 8 hours, which is what pump A did, and pump A was larger. All right, let's look at another example of work problems. Okay. So the question that I want to think about before we begin is the part of the work done in 1 hour. This is what this is talking about. Let's say that you can get your homework done in 2 hours, right? So we're saying the amount of homework you get done, it takes you 2 hours, which means that how much work will you get done in 1 hour? Well, if it takes you 2 hours, then it should take you half an hour, or you should have half your work done in 1 hour, right? So that's what it's saying. It's saying how much work are you doing in just 1 hour if it takes you 8 hours total. So if it takes you 8 hours total, how much are you doing in 1 hour? Well, 1/8 of the work. All right, so looking at the next example, we have 2 people, Teresa and John, and they are working together to paint a living room, okay? John can paint it in 8 hours by himself. So John can paint in 8 hours just by himself. Teresa, if she was going to paint by herself, it would take her 10 hours. So the question is if they work together, how long will it take? So you know that it should be less than 8 hours because they're working together, okay? So what we have to do is we have to set up the table. So remember, first we list the names by themselves. So John and Teresa. And then we list them together. So if they're together, how much will they get done? All right, so then hours total. So hours for the entire job. So John, we said, okay, well, let's just make the table first and then we'll fill in the information. So the hours for the entire job, and then how much work they get done in 1 hour. So the part of work done in 1 hour. Okay, so John will take 8 hours to do the entire job, which means after 1 hour, he should be 1/8 of the way done. Teresa takes 10 hours, which means after 1 hour, she should be 1/10 of the way done. Together, they're going to take X amount of hours. We don't know really how long, but X amount, which means after 1 hour, they should be 1x the way done. And we know that working together, that John's part plus Teresa's part after 1 hour should be equal to the work done together. So now we have an equation. We know that 1/8 plus 1/10 has to equal 1x, 1 over x. Okay, so now we kill our fractions, right? So looking at here, we need a least common multiple of 8, 10, and x. So the least common multiple would be 40x. Okay, so we'll multiply every term by 40x. And then we'll simplify. So 8 goes into 45 times, 10 goes into 44 times, and then x goes into x. So we're left with 5 times x times 1, that's 5x. We're left with 4 times x times 1, that's 4x, equals 40. So that means 9x is equal to 40, which means x is equal to 40 over 9, which if we make that into a mixed number, let's see, 9 goes into 44 times, that's 36 with a remainder of 4, so 4 and 4/9 hours, right? So together, x is 4 and 4/9 hours. It will take them 4 and 4/9 hours to paint the room together, which in the overall idea makes more sense because it's less than what it would do if John was just by himself, right? So the answer makes sense. All right, go ahead and try some problems on your own.